Okay, Algebra 2, please go to 615 for me. There's a ton of words at the top, and then a key concept box, and then there's a formula, an equation at the bottom as well. So go ahead and stop the video and read 615 for me, and then I will see you on example 1 on 616. So, example 1 on 616, it says write an equation of an ellipse. Now, hopefully you just read about an ellipse. It's basically an oval, okay? Ellipses are like ovals, and there's a lot of words that we will talk about in a second from what you just read. But the standard form of an ellipse looks like this, okay? It's x minus h squared over a squared, la-di-da-di-da. Today, we are going to have the center at the origin, okay? The center at the origin. So our h and k will be 0. So if I said x minus 0 or y minus 0, it would just be x squared and y squared on top. Does that make sense? If it doesn't, please leave a comment, all right? Since the origin is the center, h and k are 0, so we're really going to say x squared plus x squared over a squared plus y squared over b squared. Now, here's the problem. Look at the ellipse that they gave us. This is a horizontal ellipse, this is a vertical ellipse. So this equation is standard form for an ellipse that runs horizontally. We need a formula for the vertical ellipse, which is this, all right? It's y squared over a squared plus x squared over b squared equals 1. So a couple of things here. Standard form, there still would be a minus k and a minus h in here, but since our ellipse is at 0, 0, the center is at 0, 0, I've just eliminated those. And what you can see is the a's and the b's stay the same in the fractions, but the y's went with the a, and now the x's went to the b. So this is, in red, this is for a vertical ellipse. This is for a horizontal ellipse. Now, and I'm going to sidetrack here. If you can't tell what the center of an ellipse is, look at the foci. All right, look at the points, right? So like 0, 7, and then 0, negative 7. What's the halfway point between those two? Well, you could do the midpoint formula, or you could just count, right? You could just count. It looks like they're 14 spaces apart, 0, 7, and 0, negative 7, right? 14 spaces apart. So halfway is 7, and if you count 7 from either of the foci, you will get to our center, which is 0, 0. Okay, so a lot of things here. Let's stay with the foci. All right, so the foci is listed as C0 and then negative C0. But this is for a horizontal ellipse. So we don't want that. We want these two, 0 C and then 0, negative C, because these are the foci points for a vertical ellipse. And if you look, the foci were 0, 7, and 0, negative 7. So what does the C value equal? Well, it equals 7. So I'm going to write that over here because we will need C later. Okay. Again, if you have any questions on this, just drop them in the comments because I know this is a tricky thing here. Okay. Now, the first thing we're going to do is we're going to look at the how to solve for either A or B. So let's just start with A. Okay, and hopefully you would have read I was about to say yesterday on the page before that the major axis, which it kind of goes from like point to point, but the major axis is like the longest part of the ellipse, right? And it's equal to 2a, right? So if you look in your book, the major axis runs vertically because this is a vertical an ellipse. It's running from 0, 9 all the way down to 0, negative 9. Okay, it's going right down the middle, and that's the major axis. So how far is that? Well, we could use the distance formula to find how far it is. But again, I think we can just count in this case, right? 0, 9 all the way down to 0, negative 9 should be 18. It looks like the distance of the major axis is 18. So major equals 2a. All I'm going to do is say 2a equals 18, right? The major is 18. We'll divide by 2, and a is 9. Okay, so that's a nifty little formula there to help us. Now here's the problem with trying to do that with the minor axis, right? Because the minor axis now will move left to right because it's vertical. But if you look left to right, is the ellipse on a whole number? It doesn't look like it. It looks to me like the left side of the ellipse is just inside -6, and it looks like the right side of the ellipse is just inside +6. So we don't really know what those are, so we can't do the same trick we did to solve for B. The good news is there's a formula that relates A, B, and C together, and you can find that on the bottom of 615. Hopefully you found it. That formula is this: C squared equals A squared minus B squared. This is very similar to Pythagorean theorem, but it's just a subtraction. And so we're just going to plug A and C there, right? Because we know what A and C are. We'll plug those in, and we will solve for B. So C squared, right? C squared is obviously 49, right? So I want to say, I'll do this here. I'll say 49 equals A squared is 81, right? Minus, now we don't know what B squared is, so it's going to stay as B squared. So I'm going to solve this equation like normal. I'm going to subtract the 81 on the left. I think, let's see here, 49 minus 81 will have to be negative, is that negative 32? Yes, looks like it's negative 32, is equal to negative, don't forget the negative, B squared. We'll divide by a -1 on both sides, and that leaves us with, looks like 32 is equal to B squared, right? Now you guys know that if we just square root both sides, it'll give us a decimal answer for B. But instead of doing that, just go ahead and peek back at the equation. Do you see this up here? We don't need B, right? We have B squared, so all we got to do is plug in B squared. We don't need to go to B and then square it again. Let's just keep it like this. Now, we also need A squared, so A was 9, so 9 squared, A squared is 81, okay? So now that we have A squared and B squared, we can literally plug them in and find our answers. Okay, so I'm going to say Y squared over A squared, so over 81, plus X squared over, what was B squared? It was 32, equals 1. And this is the equation of the ellipse in example 1. Okay, so a couple of things here, guys. I know the quiz is coming up. I want to let you know right now, I'm not going to put an ellipse on this quiz. Okay, I just wanted you to practice some. And the one I want you to practice, we're going to stay on 616. You're just going to do example 1. It's guided practice 1. Okay, so it's just below the problem we just did. All right, remember, I'm not going to put one of these on this week's quiz. Maybe next week's, but not this week. I want you to practice, though, because we're going to get a little deeper into ellipses next week. Okay, so go ahead and try guided practice 1. And if you need help, let me know. But other than that, good luck.